Once upon a time, there was a girl. She was like any other high school girl. She was smart, funny, she liked ice cream, and was nauseated by Miley Cyrus. For all intents and purposes, she was average. Until one day, tragedy struck. In physics class, this girl got her last test of the quarter back only to be horrified by the result. Let's just say the grade was less than flattering. So, in the fashion of improportional reactions, she did the only thing that made sense. She turned to a life of crime. And thus, Pandora the supervillainess was born. She made it her life mission to complicate the lives of superheroes across the globe and release chaos and misfortune into their respective environments. But Pandora was a villainess with big plans, so she went right for the Man of Steel himself, Superman. Metropolis City, the home of Superman, had been quiet for quite some time with all the major supervillains locked away for the time being. So when Superman heard a cry of help from a very familiar damsel in distress, he was more than surprised. Regardless, he sprang into action. Superman pushed off the ground with tremendous force, which caused the ground to push up on him with the equal and opposite force, allowing him to jump. This force pushing up on Superman is equal to his mass multiplied by the acceleration as he jumps. Superman jumps in a perfect half parabola up to the top of the building where the damsel in distress was being kept. His initial velocity can be separated into vectors, velocity x and velocity y initial. The x velocity remains constant throughout the course of the motion, while the y velocity accelerates at a rate of negative 9.8 meters per second, the acceleration due to gravity. Superman's motion can be described and predicted through the use of the kinematic equations, which allows Pandora to leave her hostage on top of the building and escape to cause trouble elsewhere. At this point, Pandora became bored with Metropolis and the big blue menace Superman, and moved her villainy to New York City to torment Spiderman just a bit. Her warm-up act to unleash on the city was to rob a candy store in the Forest Hills district, just to antagonize Spider-Man in his hometown. Spider-Man, right on cue, sensed that something was happening at his favorite old-fashioned candy store, and prepared to swing down to put an end to it. At the top of the building, Spider-Man had a gravitational potential energy that is proportional to the height of the building he is on. Another nifty quality of Spider-Man's gravitational potential energy at the top of the building is that it is equal to the kinetic energy he would have at the lowest point in his motion. By setting the gravitational potential energy at the top of the building equal to the kinetic energy at the bottom, one can find the velocity Spider-Man is moving at the bottom of his swinging motion. Throughout his swinging motion, Spider-Man would be moving in circular motion, meaning there is a centripetal force pointed inward towards the center of the circle he is moving in. This force can be found through multiplying Spider-Man's mass by the velocity we found earlier squared. Then, divide this number by the radius of the circle and voila, you have the centripetal force. Unfortunately, during the time it took Spider-Man to swing down to the candy store and find his velocity and centripetal force, Pandora was able to get away with all the money from the candy store. Pandora's candy lasted her all the way to the beach, which was the next place she was going to cause trouble. She spent a lovely afternoon kicking over sandcastles, replacing tanning oil with cooking oil, and getting herself into other shenanigans before retreating into the ocean. But suddenly, Pandora found herself faced with none other than Aquaman, who seemed more than displeased with her actions, so she attempted to outswim him, which worked fine enough until she realized how far under the water she was going. Aquaman is a being of strength comparable to that of Superman, so he had no problem supporting the water pressure at most depths. Pandora, on the other hand, had some issues. When underwater, one has to support the force of two pressures, water pressure and the atmospheric pressure. The atmospheric pressure is constant and is added to the pressure of the water, which is density times acceleration due to gravity times distance from the surface. These two pressures create an immense force on both Aquaman and Pandora, which can be found by multiplying the pressure by the surface area of their shoulders. While this force is normal for Aquaman, it was too much for Pandora and she had to retreat to the surface. Finally, somehow, Pandora found her way into Gotham City of all places. Overly exhausted from her previous adventures, she settled for lighting dumpster fires and freeing the inmates at Arkham Asylum, before walking the streets to admire her handiwork. Until, of course, she was scooped off the ground by none other than Batman. Batman's grappling hook, which hooks onto a target and pulls the user up to said target, was able to apply enough force to both Batman and the captured Pandora to pull them both up to the top of the building. This force is equal to the combined mass of Batman and Pandora multiplied by the acceleration as they leave the ground. This force, in order to pull them both up, has to be greater than the force of gravity pushing them down. Since the mass involved in both forces is the same, the acceleration of the force of the grappling hook would have to be greater than the acceleration due to gravity for it to work. However, in order for the force to not physically harm the two of them, the momentum of this force has to be lessened. To do this, the time in which it takes the grappling hook to pull them up is extended throughout the use of an elastic rope. Now that she was caught, it's game over, really. Where does Pandora go from here? Batman, of course, had an answer for that. Summer school.